Okay. Welcome to IT Security Labs, and thank you all for joining me tonight. I'm very excited that we are here, and today I want to talk about the recent zero-day Microsoft vulnerability. It's called follina. So it's good to see everybody who is here, and thanks BT, Marshall, and Christian for joining. I hope by the end of tonight's live stream, we understand how to actually do the exploit using this recent zero day. And then we can look for indicators of compromise or IOCs in our security onion intrusion detection system. So the goal is, how does the vulnerability work? What does it look like when we kept the traffic to send to our intrusion detection system? So right now, I already have a Windows 10 machine here that is Microsoft Word, and it's ready for us to test this follina vulnerability to pop up, let's say, a calculator. So welcome everybody. So here's the deal. We're going to start by saying what is this vulnerability and what happened over the past week. So if you have been following along on the news or Twitter, you probably heard about this like last weekend. And this is just on May 30th, there was a vulnerability that was found, at least Microsoft acknowledged it then. And it's just a vulnerability. In this case is called follina, and it was the name that it was given. And it's a remote code execution vulnerability that takes advantage of the Microsoft Windows support diagnostic tool. So what happens is we try to have a Microsoft Word document with some information in it, and then we crash the Word document. The diagnostic tool pops up, and that's when we can hijack that tool and have it download a payload from us or do some other interesting things from us. So thanks for joining us, and I'm very happy that you are here. With that in mind, I have this article here that you can read and really try to understand what's happening. But I'm going to show you the few steps that you need to take in order for you to execute this vulnerability on your system. I would like to warn you, though, that if you use Microsoft Office 365, it will not work. So it didn't work for me when I was using Microsoft Word installed from Office 365. Instead, you need to download just the Microsoft Word tools. Just Word Teams without the Office 365 suite, because that will definitely mess with things. But here are a few things that you need to do in order for this to work. So we're going to create an interesting Word document here. I'll show you the process of creating it. And in fact, let me show you where I'm getting this information from, so that you know. But it's a very simple process. Let's see. There's already a POC that John Hammond made. I want to show you the manual laborious process so that you don't just push a button and do it. But if you don't care about what happens with the Word document and things like that, you can go on John Hammond's website and just run his scripts. But at that point, you just become a script kiddie who doesn't really know, like, okay, how was this done? But there is a bunch of scripts here from John Hammond. And we even have a Netcat here as well, so you can get a reverse shell. I will not be showing you how to run this. Instead, I'll show you how to run it by hand, which is the original one. So here are the few things that are required. Remember, our goal is to create a Word document. In this case, we need to add a bitmap to the Word document, and then edit some of these parameters here to make sure that they actually work. So give me 1 second and let me add them for you. All right, so let's go back to our machine and let's just create a new blank document. This is where you start, or this is at least where an attacker starts. The first thing is they need to make sure that it's a bitmap document. Let me find it here. Give me 1 second. Because I really want us to do it by hand so we know exactly which parts we modified. And then after we know which parts we modified, then we can actually look for the indicators of compromise. Come on. Give me 1 second. Let me find my document here. Otherwise, let me know where you're joining me from. I know we have a lot of people who join these live streams from all over the world. And thank you. This content that I create here is definitely not for everyone. Very few people actually like to watch live streams where ethical hacking is happening. And if you can follow along with me, and if you've been with me for a while, I would like to thank you for that. Thank you for joining me. All right, so I'm in a Windows 10 machine. I have Microsoft Office deployed. And you need to use the Office deployment tools. My Windows 10 machine is a virtual machine here. So let me show you where it's actually hosted as well. Come on. It's hosted in VMware. And as you saw, it just recently powered off. There's a timeout on the VM. But I'll show you exactly how it's set up so that you know. So here is a virtual machine in VMware ESXi, which is just a hypervisor. And we have a Windows 10 machine right here. I'll go ahead and start this machine. You need to look for the Office deployment tool. So this will actually give some of you a chance to follow along with me as I do this. Oh, nice. If you want to test this, all you need to do is go to a Windows 10 machine. Please don't do this on your main Windows 10 machine. See Palm Beach, Florida, or Canada. Nice. Texas. West. Oh, Tennessee. I see some Canadians here as well. Yeah, thank you all for being here. This is, if you want this exploit to work the way I'm going to show you today, please download your Microsoft Office from here. So go to this link that I'm going to post in the comments. Do not install Microsoft Office from your Office 365 subscription or anything like that. It will not work. It needs to be from this one, because I couldn't get the exploit to run. So download free Office from here. You don't need to even activate it. Just download using this tool here and install it. All right. Once you download it, it needs to be on a Windows 10 machine. So I'm going to sign into my machine right now. Philip is in Minnesota. Nice. Yeah, what is the weather right now outside? I'm also in Minnesota here, and I'm curious. Phil is saying it's cold out there. Can't be any colder than those in Canada. All right, so we're signing into our Windows 10 machine. It just had to restart for whatever reason. Then what we're going to do is we're going to come back and follow these instructions here. We need to make sure that we have a bitmap item, which is like a picture in the image. Then once we have the image, in this case, it could be any Microsoft Word document. In this case, we need to inject a bitmap. Then we need to edit this part here. I'll show you exactly what you need. Another part before you even start for this to work, you need to install 7-zip. 7-zip is a tool for zipping files. So first, open your Word document. It can be any blank document that you have. So let's let it actually pop up, and then we will show you how it's done. So as you can see, I'm just starting with a very basic Microsoft Word document. Nothing really is loaded already. We just start with that. And as you can see, this is part of my detection lab series. And then let's open any blank document. Hey Tim, thank you for the super chat. I really appreciate it, man. Techno Tim, please go ahead and check out his channel as well. He has a wonderful home lab series. If you like any automation, Techno Tim is the gentleman to follow. So thank you for that. All right, first, here's a blank document. We need to go to Insert. Then it needs to be just any like regular document. Let me see, where do we go for that one? All right, let's see. Give me 1 second. I forgot where that bitmap was. Was it Word Art? It's somewhere in here. I just have to look at the documentation here quick. All right, it's in the insert or design. Let me see. All right, just give me 1 second here while I get my bearings down here. So a blank document first. Okay, then once you have a document here, in the insert, we need to insert it as a bitmap or even an image actually. Last time when I was checking, I tried an image as well. Now I need to find out where is my bitmap. Give me 1 second here. It's somewhere. Okay. I'll just insert this one here. Once you insert an image into your document as bitmap, the next thing that you need to do is make sure that you just save that file. I'll save this in my documents. Yeah, I'll show you here in a little bit. Okay, so I already saved one called bed.docs. That's the same one. So I won't bore you with that one. Then once you have a document, this is us. By the way, what we're doing right now is we're weaponizing a Word document to get ready for it to be used for the attack. Okay? Now it's actually trying to get me to sign in. I don't want to sign in anything. So I'm just going to ignore that. if you go to your documents, you need to right click on the existing document that you added an image or a bitmap image, then do a 7-zip open archive. This is the manual way of attacking things. Let's give it a second here. All right. Then from here, there's a few places you need to edit. One is in the Word, Rails. This document here, you need to right click and edit that. And if yours doesn't look like this, you need to go to the view. I think it's format, word rep. Make sure that it says word rep here. Right. This one is already edited, but this line here, actually this one, we need to add a few words there. Let me show you what you need to add to make this exploit work. I know this is the boring stuff, but it's also the important stuff, because you don't want to just go out there and just start running people's scripts without knowing like what did they actually modify. So we need to modify, I think, this ID 4. Let's check here on our documentation. Create a dummy document, insert an O object as bitmap image, save it in as docs. So we did step number 1. Edit Word, Rails. That's what I just showed you right now. That's the second step with 7-zip. Modify the XML tag relationship with attributes. So in this case, target is equals to embedded.bin by changing target value to target mode and put your payload. All right. Let's actually do it with one that's already there. 7-zip, open archive, Word, Rails, document xml.rails. All right. View. Like that. So it could be any word really. Make sure that you do a format word rep for this to make sense. Then in here, we need to search for the attributes that we're looking for. So we need to look for target and we need to add target mode external. So you can look for this embeddings here and replace that with your target payload. So let me show you what that looks like. This is actually not as nice to look at. All right, so somewhere in here, we do have our target O object.bin. But for me, I actually had to go in there and change it to replace it with an HTTP payload target. For you, you need first go to your Kali Linux, identify what your IP address is. Stop that. PA. So my IP address is 192.168.38.186. So I need to go back here. .186. Come on. I need to go down. Wait, what's happening here? I need to take a step back, make sure that I went to the correct one. Word Rails document xml.rails. Okay. Word Rails document xml.rails. Okay. Then edit. Okay, I don't know what was happening there. So this is the line, the third one from the bottom. You need to make sure that your target points to your exploit HTML file, just like what I have here. The original one will not have this. The original one will have this object.bin. That's the first one. Then, of course, for mine, for formatting purposes, I edited it a couple times. Yeah, I didn't have the correct one. Yeah, for formatting one, this is exactly what mine looks like. So I'm putting the target machine, which is the attacker machine here. So this is how we edit the first part here, which is right here. Then we need to edit target mode to external. And then we need to go back to Word, then do an edit document.xml as well. And to do that, let's just close this. Just on the regular Word here, you need to edit this one. Okay. All right, let me see if this one will, yeah, this is the way it looks. And right here, it will tell you like, hey, by the way, you need to change the type equals embed to type equals to link. Then update mode is equals to on call. These are attributes that are right here. Let's see if I can find them. This one also looks kind of funny. So let me make sure that I go back here. Word document XML. Search for the all object. Actually, let's search for this one. So we don't even worry about it. And here is our document.xml. Edit. Search for this. So it's somewhere down here. As you can see, I was able to find it. And then we need to update this. The mode needs to be on call, just like what it says out here. All right, so once you have done all these steps here, which look tedious to you, but it's kind of interesting to see like, okay, how is it set up? Then we can set up our payload. In this case, we're just popping up a calculator. You need a payload.html that resides on your Kali Linux machine. And also, in this case, if you're like, okay, that was too much work and I can't follow along with that, here is an automated version of it where you just be clicking around. John Hammond just created a Python script that will do all that work for you. Like we did it by hand because we kind of wanted to know like, okay, which parts of the Word document are we messing with? How are we able to call back to our Kali Linux? But if you're like, okay, I'm done with that, you can just come in and run this one here. It's a pre-made exploit and you'll be fine. But for us, we're doing it the manual way, the hard way. Save the POC. In this case, it's going to be a calc launcher on your Kali Linux. So what you would do is, I'll probably just come here and clone this repository. Here's a sample Word document if you wanted to. So this is what it should look like. This is what I was editing. I'm already servicing the POC from here. So I have my payload.html here. Let me show you what's in there. So my payload allows me to, in this case, pop up the Windows diagnostic tool, the Microsoft diagnostic tool. In this case, it's going to launch a calculator, but you can make it do anything you want. You can have it launch, let's say, a reverse shell with Netcat or whatever. But this is the file that will be dishing out to our victim. And the way it works is, if I say Python 3 -m http.server, and I give it on port 80, I can come back to my victim machine. Now that the other file is already pointing there, it will download that POC HTML file that I'm hosting and run the diagnostic tool. And once the diagnostic tool is ran, it will spawn calculator as a child process. That's where our detection is going to be based on. So we have a Word document that is laced with an image. Something crashes during that process. It reaches out to an external server when it pops up the diagnostic tool. And that external server is running a command to pop up a calculator. That's how this is going to work. So for detection purposes, we're more interested in, okay, let's use another account. We're more interested in, okay, we spawned a diagnostic tool that spawned child processes. And that's how we are able to go and actually try to see, can we detect that? Should we be able to see that? So I'm going to double click on our poc.doc here. I'll share with you these files. I borrowed them from someone, I think on Twitter. I don't remember, it was last week. But it's very easy for you to do the manual way that I'm doing here. So as you can see, this is the diagnostic tool. The moment it pops up, let's go back quickly. It reached out to our HTTP server. You see the IP address here. It did a get for exploit. It was a 304 because it was a redirect. Then we did a head on the file. If you go back here, we should have a calculator pop up right now. So the exploit worked. We have a Word document that is laced with the ability to pop up a calculator. And let me show you again where that is. In 7-zip. Okay, I can't do that while the file is up. So don't save that. Don't mind the POC document has a small claims notice. It's supposed to be a real legitimate document. I'm not getting sued or anything. All right, so it worked because right here, if you go to Open Archive again, Word, Rails, and edit this, right here, we are pointing to our external server. That's how it was able to reach out to me. This is where the secret sauce is. So once you know that, we're going to execute it one more time. Let's watch this side here. We should see right there. It went very quickly. It reached out with a GET request, and then we ran a head as well. Go back here. If we wait for a second, a calculator is going to pop up, if it hasn't already. All right, so that's a 0-day. How bad can this be? We can get it interesting, right? We can be like, okay, instead of having it start a process, right here, here's what we're going to do. We're going to replace this with a Nisheng, for example. And then Nisheng will actually just go out there and, excuse me, Nisheng will just reach out back to us and we'll get a reverse shell. Either way, we're executing and we're spawning child processes on the system. So who actually started this process and how do we detect it? Because at the end of the day, I mean, we can know how to run it all we want, but what does this look like on the network? Well, you're in luck because on this host here, I have an OSEC agent that is running, or also known as a wazuh agent. It's running and it's collecting Sysmon events and Windows event logs. So we are sending all that information. We even have some rule sets here. Oh, wait a second. Maybe this is where I should have added my rules. Okay. That's interesting. All right. So we are running an agent, and this is where we have some rules for the OSEC agent, a wazuh agent. Going back to Security Onion. Out of the box, we might not see alerts, but we should be able to go and track down what happened. And your job really from tonight is you're going to understand, okay, what actually happened there? Can we see the traffic when we have host-based intrusion detection? And hopefully you'll be one of the few people who will be generating alerts out there. Oh, that's interesting. This thing didn't generate any alerts in the past hour. Let's say 2. Okay, but I'm pretty sure that we saw the data. So we didn't get any real alerts because we probably don't have a rule for like Suricata or even the detection here. But that will not stop us. We know a few things about this. One is we use this tool called the Diagnostics.exe. So we are going to track it down first. If you're curious, reading from this article here, I don't know if it says that. But this is a service that launched when things crashed and when we reached out. So this is what we're tracking. If this thing here has any child processes, we would like to know about them. This is not a bad tool inherently, but in this case, it is the one that is spinning up the actual exploits. So right now we want to see there's going to be like a failure. This is from Windows event log. All right, so when you go to work, I'm hoping you'll be using this for your employer. The first thing is we need a correlationship between this Windows diagnostic executable with all its child processes on Windows. I found an article for like detecting. So you know that I'm not just making this up. And I'll share this one with you as well. It's in the comments. So how do we detect it? First, you will see the processes that you launched. So we launched calc.exe instead of notepad.exe. We should be able to go and see calc.exe if everything worked the way we like. I don't need 2.exes. All right, so calc.exe shows up in our SIM event. Smart intrusion detection people are going to have this correlate to the diagnostic tool. So they are going to look for any child processes that results in, say, system calls to external IP addresses that came from our good friend, the diagnostic tool, which is this one. So if you are smart, you start with saying, I would like to get an alert when this fires, and it spins up child processes like PowerShell, like command line, cmd.exe. And those child processes result in external system calls, meaning they're reaching outside. But for now, we know we have some of this. We also executed calc. Let's check to see if this calc.exe shows us who spawned it. So I have an event here from sysmon. The only time that we have opened a calculator on that system was using this. So here's 192.168.56.104. It's a multi-horned system. So if we minimize this, I'm pretty sure that this is 104. Yeah, 192.168.56.104. So this is our system. This is the system diagnostic tool. Now let's go back here and say, okay, we do see calc was spawned. So you and I, we are learning now together. Let me make sure that you can see this. Here's a message. All right, so this doesn't show us the relationship between like which service actually brought it up. But at least we see that we do have calc.exe, which was spawned here from the service host, and it was captured by sysmon. Sysmon is a tool that we put on Windows to collect system events. So if you haven't done host-based intrusion detection system, this is coming from sysmon. All right. The user that it ran as was NT authority system. So what this tells you is that if we didn't spawn the calculator and we ran like a reverse shell, we'd have gotten it as system administrator, which is kind of scary to think about it, because we'd have been NT authority here. All right, let me see. So this came from service host. It wasn't triggered by the diagnostic tool, which is interesting. Let's pick, this was from sysmon. Let's pick one from win event log from Windows events. So instead of sysmon, let's look at Windows events. All right, let's execute. I have to move myself out of the way so you can see. All right, so here's our calculator that we spawned again. This time, I'm hoping to see if, let's look at the full message, if there's any relationship. No, we actually don't see it as well. We just see the calc.exe. Next, let's take it further. This is our culprit, by the way. This is the one that is the secret source. Without this, nothing else would happen. And according to this document here, we are looking for any interesting connections to that. So let's go back and search for that one. We have 138 instances where the system diagnostics shows up in the last probably 2 hours. And our system is a Windows 10 machine here. Again, we see sysmon and Windows events showing up. Let's look at security. Again, we verify this is the same host. This one is showing us when the process actually spawned. It doesn't show us the relationship between this process and the calc.exe that we executed. So what does this look like for you as a defender? You can do an AND. If you can get results that include both of them in the same transaction, then you have yourself a nice alert. So I did a system diagnostics, which is the one that's generating my calc, which I executed, and this came from WinLog events. What does that look like? Oh yeah, it's nice to see these two in the same sentence. So I'd like to see what happened here. All right. So the process name was this one here. And from the command line, we executed calc.exe. If anything, this is how you would write a detection rule. I would write a rule that matches something like this. So system diagnostics launching PowerShell. Now that's interesting. System diagnostics launching Netcat. That's interesting. System diagnostics launching the command line, or even just reaching out to the internet or anywhere. That's very interesting. So this right here is a good telltale sign that we can create clever rules. If you're curious, like, okay, how do these rules work? I found examples that I could not get to work, by the way. I really wanted them to work, but I couldn't. Here is how the rules, detection rules will be written. If anybody gets them to work, please let me know. I didn't have enough time to test them. But these are the wazuh agent rules for this. And they follow the same syntax. They're using Windows event log data. So they're looking for when a Windows document is launched. Actually, let's edit further. A Windows document is launched. You see diagnostics pop up after Windows document is launched. Then you see PowerShell launch up. Now you have three interesting things. That alert is worth people looking at it. Okay, so Microsoft Word was launched. The diagnostic tool launched. Command line launched. And the wget command was issued to reach out to the internet. That's interesting. So here is the rule that you can use. I really wanted this one to work, but as you can see here, it's using run DLL32 to look for Microsoft Office to be launched. Then once Microsoft Office is launched, I think it's also looking for winword.exe or Excel or PowerPoint in this case. It's just looking for the process ID once that happens. In this case, it's using sysmon. And then they actually were not looking for the diagnostics tool, which is kind of interesting. So maybe that's why this thing didn't even alert me. But this is how the rules are written. And just very quickly, I'll show you where you can put these rules. So you become a very well-rounded person after watching this. In Security Onion, you have an NSM wazuh rule set rules log here. You can put any rules in XML format. And I just added this one today. So this is what the rules look like once they're deployed on a host-based intrusion detection system. And here are the same rules that you were looking at that I couldn't get to actually trigger. But at the end of the day, like we said, we can see that we do have indicators of compromise, and we can track them down to here. Just to make sure that we do this full circle, let's search for our file that we delivered. This is from the network, by the way, payload.html. it should have been seen moving across my network if everything worked. Was it exploit? No, I think it's payload. Oh, I know why. I forgot to mirror the traffic going there. So my intrusion detection system is not seeing the network traffic because I was so focused on the host-based traffic. But you can also see that traffic move across the network. And I could have actually captured it with Suricata. Give me 1 second. Let me change my configuration for the lab and we'll run it again. We should see this file. Give me 1 second here. And I'll show you what that looks like as well. Once I sign in. Some of you are hackers over here. Come on. All right, so I'm going to show you how the mirroring of the traffic works. Then we can see this data moving. Because one thing that I want to see is if I had moved the Word document across the network, it would have triggered Strata for file sharing, and also Suricata would have captured some of these things. So I missed a whole lot of events by not using host-based intrusion detection, and I'm not happy about that. All right, so I'm going to show you the mirroring of the traffic. So let's go to the switch. That one is spinning. Come on. Okay, so we're going to mirror traffic. You probably won't be able to see this. Mirror port 3. Is it port 4? Apply. All right, so we are now mirroring the traffic. Let me show you what it looks like. Well, that's why we didn't have any data. So now, let's trigger the attack again. Let's clear that. Python 3, HTTP server. Let's open a document in our downloads, poc.docs. Would like to watch as this is happening. So you know I triggered the document. I want to show you this in real time here. So here's our strongly worded letter. Let's do it again. All right, there we go. And it happened very quickly. So we moved a file called exploit.html. across a network. And I'm capturing the traffic now. So let's see if I see any interesting alerts. Let's go to alerts. It's processing them. All right, so Striker probably didn't see that, but after the indexing happens, I should see that file move across the network. There we go. So it can be any raw demonstrations than this. I just moved the file across a network, and here is 9 instances where that file was seen. Well, we want to see what that looks like. It hasn't been indexed yet, so maybe, come on. The source IP address was 192.168.38.199, because that's the one that was reaching out to us. And after everything, after it indexes here in a second, we should be able to actually see the file somewhere in here. It takes a while for Elasticsearch to process everything, but we have 9 instances where that file happened. To make sure that we prove that it actually is working, let's do it again. Close calculator. So we had 9. If I run it again, we should have more than 9. All right. So it's indexing. Now we have 18. So it kind of makes sense, right? We see 18 instances of that file. The interesting thing is I can't see the logs. Come on. Maybe this thing is not indexing fast enough today for me. It's telling me that there's 18 events. I want to be able to read them. So let's see what that looks like if it indexes. But what we're doing here is really just trying to track down these indicators of compromise and trying to understand, okay, what really happens. So I have 38 HTTP events from that host. So I'm just going to click on those. We're trying to understand, okay, what happened? What does the traffic look like when you go to work? This is the kind of stuff that you'll be seeing. And if you can see it in your own home lab, you'll be able to play around with it and really know how to interact with these things, which is kind of nice. From our real events here, nothing really triggered. So this intrusion detection system needs these rules that we have already for detection. They need to be implemented. All right, so coming back here. Let's look for the source port. Not wazuh. Of 80. Really? All right, so I see destination port of 80. The only thing that I've hosted on port 80 in this lab environment over the past hour were those files. So we should see a bunch of GET requests here. This is you trying to track down how the attacker sent. So here's the http.uri of exploit.html. So now we can verify that this exploit actually was indeed delivered. So if you see HTML data being delivered after a wazuh agent ran the diagnostic tool and triggered PowerShell or the command line, and in addition to that, it reached out to an external server that had an HTML file. I mean, that's a very involved rule for detection here, but this is what we ended up with. And as you can see, we captured it all. This is on the network. This is not host-based intrusion detection. This is now network-based detection complementing host-based detection to make sure that we have very interesting events. We can pivot to Security Onion Hunt interface. This is what analysts would do, and I like to end our live streams on this, where we actually end up collecting the artifacts. We can't just end this without collecting something, right? So this is the same thing. We reached out to this exploit.html. Can we get a pickup for this? What kind of intrusion detection system won't give you a pickup, right? You need a pickup for you to be able to see how things work. So this is the typical TCP handshake, who done it kind of thing. And this was a head. Oh, this is not a get. This is not interesting. This is interesting. So this is not the get request that we did. This was a head, but that's okay. Because if you look here, look at the user agent. It's Microsoft Office. It's not every day that you see Microsoft Office as the user agent. So this calls for, again, more interesting discoveries as far as people who are writing detection rules for this. Maybe this is an area where you want to also add, if you see a user agent, is Microsoft Office in your network data, and it's downloading an HTML file. Maybe you want to keep an eye on that, because Microsoft Office should not be reaching out for HTML files somewhere. I mean, it shouldn't, right? But here, user agent is actually set to Microsoft Office. So tools like Stracker that can actually be used for hunting, extracting files that are moved across the network, they should be able to see this. It actually says, in this case, mine was an Python simple HTTP server. We have it here. Let's see what else. All right, so that's interesting from a pickup perspective as far as how you can see this type of Microsoft zero-day attack. If anybody has written rules on this, please let me know, like, the things that you actually ended up using, because this is very fascinating to me. And us playing around with it also gives us a very safe environment to practice and just educate ourselves like what we're doing, especially with pickup. Because if you are not employed and you're not doing detection as part of your main job, you probably don't have the ability to do this and verify how things work in an environment. Okay, so let's look at this in Wireshark. I just pulled the pickup the way it is. There we go. And as you can see here, goes to from Kali in my itsecurity-labs.local to Windows 10. And there's our head. We don't have a get. So the good thing is probably look for the get request. We have head for this one, and this is what it looks like. Oh wait, I'm on the way. All right, here is a head. By the way, where is this head coming from? If you just join me, I would like to show you this one. So from our attack machine, this head here can be seen moving across a network in Wireshark all the way up to here, which is very, very interesting, right? At least I hope you find this interesting. All right, let me look at the chat now. Holy smokes, we're getting spammed here. Let me ban this person. Like, who is doing that? All right, sorry about that. All right, I think this is the time when I hand things to you. Let me know which are the parts of this exploit that we just did you'd like me to explore. But by far, this is the most exciting stuff that you can do as a cybersecurity person. Spin up the proof of concept for an exploit, capture all the traffic, mess with it, see what happens, quench your curiosity thirst by making sure that you see what you want to see. Then when you go to work, you can actually not spend too much time breaking things. Maybe you can do this during your work day if you're doing it for your employer. But with this here, I'm going to, is it export objects? These are HTTP objects. I'm trying to see if I can get the file. No, I can't. I can't get the file because we ran this head. It should be on the get request for me to get the file, I think. Don't quote me on that. The get request should be the one that gives me the file. The head request, I'm not sure. Asmin has a command for me to run here. You want me to look for event code 4688. Let's go and check that one out. This is not Splunk, by the way. I think the query that you gave me looks like a Splunk query. So let me look for 4688. I don't think that's a field within Security Onion. Let me look for 4688 in the last hour, maybe 2 hours. I don't have a big SIM, so I can afford to just type numbers here. If you have a production environment, don't do this. Okay. So win event log, I hope we have hits, which we have too many hits. Let's pick on this one. Event.code. Okay. So we do we do have those events. Let's look at what does it look like. Oh, this one caught Google Chrome, so this is not the one. And I think it's process.name. In this case, you wanted msd.exe. dt. Okay, so I don't have that event code corresponding to msdt.exe, but no. So it looks like they spawned over here, which is interesting. I'm picking at random events here. All right. Let's see. Do I have a creator? Creator process name. This will be anybody though, so this doesn't catch anything. And we crashed our sim. This is a good sign right here. Anyway, as you can see, we can try to track these things down and be able to see. I just crashed my sim by running wildcards. All right. I think that was really fun. If you like this kind of stuff, please make sure to like these videos, and also remember to subscribe. I enjoy being able to go and mess around with these interesting tools and be able to come to some form of conclusion. And thanks Techno team for showing me that there's a lot of good people out there, and all your support and the super chat. Really appreciate it. But if you have any questions, any suggestions, please make sure to put them in the comments. Next week, we'll be back again doing something similar to this, but even more fun. I will be making a machine, so stay tuned and watch the community channel. If you haven't, please subscribe so you can be notified. And I'll be posting a brand new machine for us. So thank you for being here, and I hope to see you next week. Thanks.